Greetings and salutations, everybody. Another beautiful day for a webinar. Let's do one, shall we? We're going to kick things off very soon. This is, geez, I've lost count now. This is number 10th of the Stormwater Fundamentals series for 2025. You'll be pleased to know. Super popular. Thank you for everyone who gives up an hour of their time once a month thereabouts to learn and discuss all things stormwater fundamentals. And people might be pleased to know that we are going to do it again next year. So we're just in the final touches of putting together the plan for next year. So stay tuned for that. We'll look to promote that in the next month or so. But it's another action-packed year of all cool things stormwater fundamentally. So this is the second year we've been doing it, and always super grateful for everyone's support and attention. And yeah, look, why not? Let's just do it again. But we're not finished with this year yet, though. So we're going to hear from Mr. Dan Rhodes, who, when we organised this, he actually worked for Optimal Stormwater, has now joined the team at Ocean Protect now. So welcome, Dan. And just a reminder before we actually officially hear from Dan, just a reminder, folks, that if you do have any questions you'd like to ask Dan today, please put them in the Q&A panel. Makes it a lot easier for us to answer your question. You can put in all sorts of sledging and commentary in the chat. More criticism, the better, as far as I'm concerned, and deservingly so. But if you put it in the question, if you have a question, please put it in the Q&A panel. Just a reminder that, as per normal, the slides from today's preso and the recording will be made available at our website probably a day or so after today. And obviously CPD forms. We're streamlining this, I think, pretty well now. I'm hoping. If you've got any dramas, just let us know. But yeah, CPD forms will be emailed to you very soon after the webinar. Cool. But look, it's been great pleasure. I might get Dan to take control of the slides. But for people who don't know Dan, look, good for you. You're not missing much. No, I'm kidding. Dan is a senior water engineer at Ocean Protect. Like I said, he actually was a part of the Optimal Stormwater family before joining the Ocean Protect team. But we are super grateful to have him on the team. But he is the senior water engineer at Ocean Protect. Based in Queensland. So he's an RPQ chartered engineer, all those sort of cool acronyms, etc. And for Phil, who might not be familiar with Dan, you might be familiar with his music because he tells me he was a rock and roll megastar for many years. Or it might just be a slight exaggeration, but no, he was a muso for about 10 years, traveling the world, wowing the masses. Singing all sorts of, everything from John Denver to, Amy Winehouse to, Kumbaya. No, he's mainly a guitarist. But so if you're keen to learn a few things, come to see me, and then I might handball you over to Dan because he's got a few things he's got to work on, but that's okay, So, but look, Dan was a muso, but he switched gears and got into the fast lane of engineering. So he was with Henry and Hymus and Optimal Stormwater for about 7 years. And there's a whole backstory behind that, so I won't go into detail. But if you're keen to know more about Dan, we actually did a podcast a few months ago, Ocean Protect podcast. So if you can't get enough of Dan's, sultry tunes today, feel free to dive into that. We talk all about GPTs and all sorts of stuff. So, but look, Dan's not going to talk about his musical career. He's talking about dewatering devices. So, Mr. Dan Rhodes, senior water engineer at Ocean Protect, the court is yours.
Wow, what an introduction. Thanks,
All right.
Brad. What a pelican you are. Good on you, mate. So look, Brad's right.
Always, Dan.
Here we go. All right. So let's set the scene. I want everyone. Has everyone answered the Q&A in the chat? By the way,
it's a good one actually. So just for people who aren't familiar, that I actually launched a poll right at the start. And it's called, and for people who should be able to find it, or should be in the toolbar. If you can see the chat or the Q&A, you should see a little thing called polls, or it should come up automatically. Oh, I can see 64 respondents. Oh, sorry, no,
Beautiful.
66 respondents already. That's only about half of the attendees, just a FYI.
Okay.
So if you haven't put in your answer just yet, but the question is, in Optimal Stormwater's experience of auditing over 1,500 GPTs or gross pollutant traps in Australia, what percentage of GPTs for their first independent inspection are either non-operational or working at 20% or less than their intended function? So there's a four options: less than 5%, i.e., they're all almost amazing. About 40%. Option C is about 80%, and option D is greater than 95%. So basically, they're pretty much all stuffed. So we're gonna have to end this poll at some point. Did you want me to do it now, Dan, or what do you want to do?
Oh, look, yeah, you can end it now. I mean, let me just set the scene. So I want you to imagine pollution and water from a wet sump GPT need to be managed. The asset owner doesn't have enough budget for maintenance. And because of this, pollution bypasses your device and ends up in the environment. So the question in the poll is, how common a problem is this out in the field? So after 1,500 GPT audits or more around the country, can I just go and drop the truth here, Brad? Is that all right?
I'll tell you what I'm going to do. I'm going to end the poll. It seemed to have flatlined at 81 response. I'm going to
Okay.
end the poll
Okay.
officially, and so I can give you the results if you like, Dan, or how do you want to play it?
Yeah, go on. Give it to me.
So look, option A was less than 5%, i.e., in
Yep.
brackets, they're almost all amazing. 2% of the respondents thought that was the case.
Good.
Option B was 40% are struggling. That was about 31% of the respondents. The option C was about 80%. That was about 37%. And option D was, they're pretty much all staffed, was about 30%. So long story short,
Wow.
between option B, C, and D, it's pretty evenly split.
Yeah, okay. Usually when I do this presentation, I get everyone to put up their hand and say, who thinks 50%, who thinks 60%, and then we go from there. So based on our data and what we've seen out in the field, turns out that this is happening 80% of the time. So 8 out of 10 devices are either non-operational or working at 20% or less of their intended function. Oh, there's the results there. Okay. So that's the challenge we're currently facing on the ground with our wet sump GPTs currently. So I'm Dan Rhodes from Motion Protect, and today is about GPT performance and dewatering. And look, the idea here is how we can get practical solutions to get better outcomes on the ground. So by way of background, Brad did touch on this. This presentation has its origins in my time at Optimal Stormwater, and I'm really glad to share all of the learnings today. So as Brad said, I spent the better part of a decade doing design, construction, rectification, WSUD and GPT audits. And what we used to say is everything stormwater, but only stormwater. So Optimal are independent of product suppliers, maintenance contractors, councils. So the information I get to share here today is off the back of that. And there you can see Murray Power, the general manager at Optimal Stormwater. If you ever have a question about GPTs, give him a call. He's the godfather of GPTs. So the idea today is based on informing everyone with a real focus on asset owners about smarter water management. We're going to talk about the benefits and risks associated with dewatering on site and how you can save some money, but weigh that up against the risks that may present themselves. So we're going to talk about the legality of the situation. What is the EPA's position on this? Then we're going to actually talk about what is on-site dewatering, and then look at the good and the bad and the ugly when it comes to this practice. And finally, we're going to talk about the alternatives of what you can do, because to be honest, you can't do this at all sites, but there are other ways as an asset owner to save money. So before we get on to the legality of dewatering, I want to talk about a very real made up example. So we've got a high performance wet sump GPT here designed to be maintained 4 times per year. Say we got 10 meters cubed of pollution stored in the sump offline, and we got about 40 meters cubed of water above that. So these are all just round numbers. And the device has a pollution storage of 10 cube and 40 cube of water, and you only have about 10 grand per year to maintain this device. So you're pretty constrained. Everyone in the Q&A who is working for council or as an asset owner that is flush with maintenance money, please let me know, because I have not met anyone from any council that has an ample budget for maintenance yet, but not to say they're not out there. So looking at two options to maintain this device, you've got option A. Cleaning contractor comes there, removes all the pollution and water from the device, and then drives that across town and disposes of it at a liquid waste treatment facility. So say you got $2,000 to dispose of your 10 cube of pollution in the sump, and then you got $8,000 to dispose of your 40 cube of the water. So what that means is with this costing, you can only maintain this device once per year. So you have about 75% of the pollution off that catchment bypassing and entering the downstream environment. It's not ideal. The second option is smarter water management, including appropriate on-site dewatering. With this, the cleaning contractor removes all the pollution and the water, similar to option A, but this time they dispose of the water on site in line with the guidelines. So your cost to dispose of the pollution is the same at $2,000, but your water disposal costs are reduced to zero. Therefore, you can afford to maintain your device all year round. Therefore, there's no pollution bypassing. So obviously option B is the more affordable option. But if you do this, what are the risks? Can the EPA investigate you and fine you for polluting the environment? So a conflict of interest declaration here. I've previously given this presentation a bunch of times when I was with Optimal Stormwater. We're completely independent of suppliers and contractors. Since then, I've joined Ocean Protect, which we do sell proprietary GPTs and offer maintenance services. It's important to acknowledge, but the reality is everything I'm saying here today, I was going to say anyway. And this content comes from years of independent audits and field experience. So when we talk about what is a wet sump GPT, a high performance wet sump GPT, look for a real deep dive on this. Murray Powell, the general manager of Optimal Stormwater, has an excellent webinar on this. I think it was a couple of months ago, but I'll give the very abridged version. So low to medium performing devices typically utilize direct screening technology, tends to block and bypass. They also store pollution in the screening area. So the CDS technology avoids these problems as the screens are non-blocking, flow remains constant, store pollution offline in the sump, and are easy to maintain. So the CDS technology patent actually ran up, I think in 2015. So since then, there's a couple of other suppliers that are offering this technology. So here at Ocean Protect, we have our Ocean Save, which builds on this technology. Easier construction, better access, higher treatable flow rates. I just want to take a quick look now of when we're talking about direct screening technology that stores pollution in the sump, what does that look like and why is that an issue? So if we look over here, we've got a direct screening technology device. Flows come in, it hits this back wall, goes down through the screens, it gets treated, comes out the outlet, and away the treated flows go. So you can see here, the pollution storage area is 0% full. You have 100% treatable flow rate. When pollution builds up in the sump, say we have 50% full, you can see that 50% of the screens are available to actually treat the water. So what that means is your design treatable flow rate is actually reduced to half. And conversely, when you're 100% full, you have 0% treatable flow rate. So say we start at 100 litres a second, we work our way down to 50 litres a second to eventually 0. So it's important to say this because here's the real kicker. Music doesn't actually show this performance loss. So if you're a council DA staff or if you're approving any stormwater treatment device with a wet sump, just know that if it stores pollution in the screening area, then music doesn't actually show that. And the industry is moving towards knowing this more, but it's just good to put it out there. So if you're an asset owner and you're sick of receiving wet sump GPTs that just don't work or they can't be cleaned, or they're just storing pollution in the screening area, you can actually adopt design guidelines to rule them out. So you don't need to name names or brands or products, but you can set clear parameters for what will not be accepted. So there is a way to get away from these type of devices if they're causing you trouble. With dewatering, so I just got to clarify the terminology because I always get these backwards. So decanting is removing the water from the sucker truck removing all the pollution and all the water from the device. And then at the back of the truck, they got usually a 1 mil screen, and then they pump it out appropriately on site. That's decanting. Dewatering is using a pump, putting it on top, pumping down the supernatant water, and then disposing of it on site. So, because I always get these mixed up, decanting, truck, dewatering, pump. Now, each state and territory has its own legislation, but the intent is essentially the same: to stop polluted water from entering the environment. You know, in New South Wales, you got the PO and EO Act. In Queensland, you got the Environmental Protection Act. But for dewatering GPTs on site, regulators can't actually give a firm position because pollutant levels are going to vary between device to device. When was it maintained last? Has it gone anaerobic? What's in the catchment? So without water quality testing of this water, the risk is actually unknown, and on-site disposal may still be treated as active pollution. The only thing consistent about water quality in wet Sump GPTs is its inconsistency. But now we've got to ask the question, what is legal really? What do the acts and regulations actually allow? So if you drive a car on the road, it's technically illegal under the PO and EO Act, as the particles from your brake pads, they get on the road, they get washed into the stormwater system, and that's actually considered pollution. You got leaves in the gutter, council owns the gutter, is therefore legally liable for pollution when it rains next. Here's the real kick in the guts. Having a device that is overfull and is allowing pollution to bypass, that's illegal. So the WSID compliance framework developed by Daniel Rhodes goes into this in great detail. Dan did a webinar late last year. If you haven't seen that, highly recommend it. So in summary, dewatering a device on site is illegal. Because of this, you can't afford to maintain your device, which means pollution will bypass. That's also illegal. So I usually give this talk and we say asset owners are stuck between a rock and a hard place because you're damned if you do and you're damned if you don't. So while the acts are absolute, the way they're enforced is a big grey area. Regulators want to achieve the best environmental outcomes possible, and our experience is if you're a council or a water authority or a private owner who's doing everything practical in their power to follow best practice to minimise pollution, they're almost always looking to support you, not prosecute you. A little bit of a yarn here. So a good example of this came in late 2023 down in Tasmania. So we had the EPA working with Hobart and Glenorchy City Council and the water authority down there, Taswater. And so Optimal Stormwater was the industry representative, got everybody in the room and said, look, we have an issue and we want to get to the bottom of it. So the issue they had was they couldn't clean any of their GPTs because the EPA had a strict requirement that everything needs to go to a liquid waste treatment facility, all supernatant water. So they're removing everything from the device and then driving, an hour across town to dispose of it. So after this meeting, while they couldn't write a new law, the Tasmanian EPA formally condoned on-site dewatering if strict safeguards were met. So these included following the guidelines, discharging only when there's a 30-metre vegetative flow path, and having site-specific documentation. So this was a pragmatic first step that set a national precedent that showed how regulators and industry can work together to find a practical solution to still protect the environment. It's pretty cool. So now I'm going to talk about what those steps were. So there's about 6 steps that need to be followed in order for this to actually occur on site. So the first cab off the rank is the national guidelines for the maintenance of stormwater treatment measures. It's an absolute mouthful, but these guidelines, they really are the holy Bible for GPT maintenance. Out in the field, there's over 80 different types of GPTs. So you've got legacy devices, you've got current models, and they all function differently, and they all have their own strengths and weaknesses. So these guidelines explain how each of these devices work, how to monitor, how to regular, how to comprehensive clean, and they have a whole section on dewatering. So these guidelines were developed by Stormwater Australia and the state stormwater associations. And there is training courses available in these if you're state-based associations. I think we have a few people from Moreton Bay Council here. They were actually the first council in Queensland to be trained in this year, and they're currently leading the way. A key safeguard in best practice dewatering is that the discharge, it has to go through a 30-metre vegetated flow path. So down in Tasmania, the EPA made this a requirement, but there is a big caveat to this, and we're going to get to those other requirements shortly. We have noted that some cleaning contractors can dewater, have dewatered directly over the diversion weir or directly downstream. It's important to note that this is a clear breach of the EPA's requirements. So the 30-metre vegetated flow path, if appropriate for that site, must be treated as non-negotiable. Now, the site-specific cleaning specification is one of the most valuable outcomes from an audit conducted in line with the national guidelines for the maintenance of stormwater treatment measures. Essentially, it condenses everything into a one-page document for that specific GPT, how to monitor, how to clean, and how to dewater, if appropriate, at the site. In addition to that, it makes cleaning tenders fair and consistent because every contractor, they're quoting on the same scope of works. So this photo here, this is typical of when you dewater supernatant water, and it can leave a dark stain on the grass. It doesn't look great, but a quick spray with high pressure hose actually tidies this up. Quick litter pick to remove the organics, and any litter that makes it out will actually restore that area to being fine. But full disclosure to the public, this can look quite incriminating. Before I worked in the industry, I would have 100% thought this was the worst. You see a combo vac truck out in a park and it's pumping brown liquid onto the grass. You just think, what the hell's going on here? So that's why signage for this is so important. It makes clear that the activity is authorised and safe, and that, backed up with the cleaning specification, acts as insurance for the client and the cleaning contractor. When I was talking before about common sense, it is spelled out in the guidelines, these. So you would never obviously dewater near a playground or a dog off leash area or a walkway. The risk of kids or pets or the public coming into contact with water is obvious. So the same goes for hydrocarbons or dead animals. Sometimes you lift the lid off a device and you just get smacked in the face by the smell of hydrocarbons. Obviously, you can't dewater. If you open the lid and you see a dead carcass in the supernatant water, you can't dewater. So this is common sense, but it is in the guidelines, put in black and white, so there's no grey areas. So what do you do if you're on site and you can't actually dispose of it on site because none of those requirements were met? So very quickly, you can discharge the sewer if council is the water authority. So this is really good for regional councils. So somewhere like Eurobodalla Shire Council, where they're the water authority, if they get internal approval, they could dispose of this supernatant water directly into the sewer manholes. Now, if you're Brisbane City Council or if you're City of Sydney Council with Sydney Water, this is obviously not going to work because you'd need a trade waste agreement and it's not worth it. You can decant back into the device when you finish cleaning it if it's a regular clean, but in a comprehensive clean as per the guidelines, you can't do that. You can decant to another treatment measure nearby if suitable. You can decant at a council decanting or dewatering facility. What's that? It sounds like it's just a really fancy term of saying an area allocated by council where you can discharge this water, it can evaporate, and then once the water gets out of it, you can then dispose of it. You can decant at a council depot into their truck washer or water separator, send to a leachate controlled landfill if council owns that landfill and they have internal approval. Good way to save money there. Can go to an irrigation area off-site, but the last option should be going to a liquid waste treatment facility. But unfortunately, if the client isn't aware of this and the cleaning contractors know this, not to throw them under the bus, they're most likely, this will be their first option because it does actually make the most amount of money for the cleaning contractor. How can we do better? So the EPA's decision on dewatering, it is a step in the right direction, But it's really, if your back's against the wall, you don't have a lot of options, your maintenance budget's small, there are risks associated with it. You can mitigate those risks, but there still is risk. So since joining Ocean Protect about a month ago, I've learned that in-house we run everything through a jellyfish filter. So the idea behind that is stripping out sediments, nutrients, and hydrocarbons. And this is just the way the industry is going. I know we're not alone in this, so other companies will be doing their own thing. But this is just a good example of taking those requirements, going a step further to decrease the risk to the environment. All right, getting towards the end. I'm Dan Rhodes from Ocean Protect, and if you haven't guessed already, my specialty interest subject is GPTs. But if you only take one thing away from today, just let it be this. Smarter on-site water management will manage budget constraints and improve environmental outcomes. I think we now have time for Q&A and looking forward to answering any
Always
questions you
have
have.
time for Q&A, Dan.
Oh,
Thank you
do
very
we?
much.
Thanks, mate.
Well done, Dan. First prezzo for Under the Ocean Protect banner and loving the backdrop. And look, we have had a couple of questions come through, but if you don't be shy, if you've got a question you'd like to ask Dan, even if you want to fess up that you thought, or maybe what I was doing is actually illegal, hey, that's okay. There's no judgment here.
I won't judge you.
There's no judgment. But one of the early questions was from Daniela Garente, which I think Daniela wins the best name award for today. Daniela is from Kingston City Council, which is in Melbourne. And Daniela says, the majority of councils in Melbourne dewater GPTs into the downstream pits, which is in brackets EPA approved. She says, I don't know any council who takes the water to a disposal site. We are actually trialing dewatering into open areas, option B, as per Dan's slides, since we are at the end of the catchment, having our stormwater ending up in the bay, but are currently testing the quality of the stormwater. I don't believe any other council in Melbourne is doing this. So to your point before, Dan, I think you touched on this. Just to clarify, so Daniela says the majority of councils in Melbourne dewater GPTs into downstream pits. She says it's EPA approved. It might be, but from your perspective, should it be, or is it is it legal?
Well, look, again, there's no actual legislation saying thou shalt not dewater into the downstream network, but there is an open-ended thing in all the EPA's requirements that it needs to follow best practice. So to minimize risk, if you're pumping directly downstream into the stormwater network, that carries a high amount of risk. So when you're trained in the guidelines and you have site-specific documentation telling you where and how to dewater with a 30-meter vegetated flow path and potentially other measures that, the jellyfish filter or whatever competitors use to minimize this risk. If you're following best practice and taking all practical steps to reduce this risk, then you'll most likely be supported. Obviously, the common sense things come in. If you smell the water and it smells like petrol, you can't dewater downstream. You can't treat it on site. You can't do anything like that. It needs to be taken away. But what I find really interesting here is you guys are doing water quality testing of the stormwater. Is that before you discharge downstream? Or
I
is
would
that,
assume so. Yeah.
yeah, okay, well, it's just so hard to get, remove everything from the device, take the
Mm,
water quality sample because they usually
mm.
take a couple of days.
Couple of
Usually
weeks
it's,
generally.
yeah,
Yeah.
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 So it's just hard to do it in real time. If we could test on site very, very easily, then we could reduce the risk even further. But it's the cost and the time delays associated with testing that doesn't actually make it practical for on-site disposal yet. The future may improve that.
So just to clarify, you're saying it's kind of illegal. Let's just say that if you don't follow best practice guidance, correct?
Yeah, you're opening yourself up to a lot of risk.
Yeah,
Let's put it that way.
and current best
Yeah.
practice guidance says don't dewater GPTs into downstream pits.
No, you need to have a minimum 30-meter vegetated flow path before going into any downstream stormwater network, any curb and gutter, any pit, any impervious surface. You need that 30-meter vegetated buffer. If you have 20 meters, then it's not going to suit. So it's pretty hard and fast, that rule.
This is a timely webinar, I think, Dan, because look from what Danielle is saying is that sounds like a lot of councils, if not all the councils, the majority of the councils are doing things in a probably incorrect way. So if you're keen to find out more in relation to what potentially is best practice, feel free to reach out to Dan after this webinar
Yeah, or
or
reach out
whatever.
to Stormwater Victoria. That they
Yeah.
run the training and the guidelines. They actually, deal out the manuals. So the information's out there. You don't need to go to a consultant. Like obviously we can help you, but go to your state-based associations.
A question's come through from Abraha, who is from, I'm going to get this right, Green Valley in New South Wales. And they ask, is this the same thing for Ocean Guard? So just to clarify, Ocean Guard stores the material or the debris in a dry sump. So there's no dewatering generally required. But we'll move on to next question. This is from an anonymous attendee. They say, thank you for the introduction to the guideline. I find it very handy. Can I have the link to download it, please? And thank you.
You absolutely can. That everybody can download the link once they contact their state-based association
Mm.
and go from there. So uh, the author doesn't have it. It's actually run by the Stormwater Association. So wherever you're based, anonymous user, contact your state-based association and go from there, and they will help you out.
So state-based association being Storm Victoria, Storm New South Wales, Storm of South Australia, etc. So, and there is plans afoot to make that a sort of national document as well. So, yeah, look, long story short, you have to pay for it though, Dan, don't you? You can't just buy the guideline.
Yeah, correct.
Cool. Okay. And I think if you buy the guideline, it comes with some training as well. Is that right?
Yeah, you have to contact them. I'm trying to remember whether you can do it without the training. There
Oh,
may be
okay.
a way to do it. But again, getting trained up in the guidelines is highly recommended because as part of the training, you'll actually go to a GPT and they'll crack the lids, they'll do an audit, and you get to see it, touch it, feel it, smell it, and actually learn what the process is.
Cool. Next question from Greg Bennett from Tasman District Council in NZ. Welcome, Greg. We have an international audience here. He asks, is there any GPTs that have had the dewatering process included in the design, i.e. an area set aside for receiving the water?
It's a great question, a good layup. Thank you, Greg. So yes, there is. When it comes to best practice design of GPTs, including a dewatering area where appropriate is a great option. Now, it's not going to work if you're in the middle of the city and you're in a concrete jungle. There might be a way around it, but if there's a bit of green space and there's a way to work that into the design, at Optimal Stormwater, just to pump them up a bit, I know that they would work that into every design where possible, because as everyone here knows, these things are only as good as their maintenance. You might have the best bin in the world, but if no one empties it, how good is it when it's full?
Cool. Another question from Anoka Sanjiwani. Great name again. They ask, can you confirm asset life if a Gatic lid opener can open it and can it be mained by a standard inductor truck?
So I guess what you're asking is during an audit, can you confirm the asset life? Typically, if you have the date that the device was commissioned, and if it's made out of a material that is Australian standard appropriate, for example, steel or concrete, then based on an audit, you can get a potential lifespan if you know when it was commissioned, what the condition is, what the remaining useful life is. So that is part of the audit if you require that information. But again, it is tough to determine a full useful life just based on a condition assessment. So a little bit, I'll give that yes and no.
There's actually been a couple of queries in relation to this 30-meter rule. I know Russell Cadman from Ku-ring-gai Council has asked it,
Russell.
and Nam Nguyen has also asked, what is this 30-meter minimum based on?
Yeah, that's right. It's a very good question. You're going to have to reach out to the primary author of those guidelines, and they will answer that question for you.
I suspect it's like a rule of thumb, like, Big Muzz has put his done that and gone, yeah, I reckon about 30 meters.
Now, I
How
reckon
far can you kick a footy?
the CS, I could kick further than that, but I think the CSIRO was involved. But look, yeah, Russ, get in touch with Big Muzz and he'll have the answer to that one.
With your chicken legs, Dan, I'm surprised you can kick over 30 minutes. But anyway, we'll move on. We've got a bunch of questions from anonymous attendee. I'm not sure if it's the one person or several anonymous, but if you could leave your name, that'd be lovely. Just to say hello, you know. Um, anonymous asks around, the dewatering to, to the ground level, the surface level. Wouldn't that contaminate the soil and vegetation on the site?
Yeah, so that's a great question. So what happens typically if you follow all the safeguards, then when you dewater onto a vegetated area, that area will be affected. You will know once you've done the cleanup and you come back a week later, you say something has happened to this area because the grass in that area will be growing absolutely gangbusters. It'll be the healthiest patch of grass there because of all the sediments and the nutrients and everything like that. Now, obviously, if there's contamination in the water and you've followed the safeguards, you shouldn't dewater on site. So
So
that's typically.
how do you know that though, Dan? Like you could say you can get a bit of a whiff and smell some hydrocarbons, but really we don't. You wouldn't really know what's in the water without testing it appropriately. So,
Absolutely, you
you're
don't.
guessing really. So
It
how do you
is,
know?
I wouldn't say guessing. I would say you are narrowing the risk profile to something that can be lived with.
Let
Because
me call my
again,
lawyer.
no, yeah, well, yeah, don't do that. Look, if you need to live between, I can't maintain my devices and I'm having meters cubed of pollution bypassing and slamming into my creek downstream, versus
Mm,
I can go through training, I can
mm,
like minimize the risk
yeah,
of this process.
sure.
And based on this, I can now maintain my device. And look, it's a great point. You're stuck
Mm,
between a rock and a hard place. It's either I
yeah.
don't dewater on site because there's a 1 in a million chance that there's whatever in there that I can't identify. Therefore, I can't maintain my device and pollution is smashing downstream. Or I follow this best practice and try and minimize all the risk the best I can in the attempt to remove that pollution in the device.
What out of interest, like what is, and it's obviously relevant, what is actually the contaminants of concern in the sump water? Like what's obviously it's got some nutrients, some sediment.
Yeah,
What do you have you got a feel for the concentrations or the type of pollutants you might find?
mate, I've had everything in there. People just pouring brake fluid down the stormwater
Good
network.
times.
I've had everything where, like, sewage comes in.
Mm, mm,
That's a massive thing if people have plumbed the sewer into the stormwater network or there's sewer overflows. And again, the benefit of sewer overflows is they're very pungent. So you can smell them, you can minimize this, but there is risk associated.
mm.
Absolutely.
Speaking of risks, anonymous attendee, a question asks, what is the worst water management practice you've seen in your career? It's got to be
Yeah,
something
okay.
Murray's done, surely, you know? No, I'm kidding. I'm kidding.
Look, because where CDS style devices are, there's typically sometimes a diversion chamber where you hop in and there's a diversion weir that diverts the flow into the device and it spins around. We've seen evidence of contractors, cleaning contractors, going in and just pumping directly downstream over that weir. And it's just evident because there's a massive mess and they haven't even tried to hide it. So we did take, as part of the audit, took photos and told the client not to dob them in, but we were like, look, this is a clear breach and you can see it as clear as day. I've seen on site discharging towards playgrounds. That's not great, like as the flow goes across the surface, it's meandering its way into a playground. Not ideal, you know. But they're the two that come to mind. I haven't seen too many besides just lazy as well. Just pump
Mm,
everything out and just bang, just put it onto
mm,
a footpath or put it somewhere close.
mm. It must be pretty average for the waterway if you just take that big pile of soup and which is full of contamination and obviously and just chuck it during a dry weather event, let's face it, typically into a
Mm.
waterway. Which brings the next question. Abra Muhammad asks, and it gets back to this 30-meter rule, Dan, because engineers love a rule of thumb. Abra asks, does discharging into a creek of some sort count for the 30-meter landscape buffer?
No, unfortunately. So if you're going into any downstream environment, you want to have a buffer in between. Like the greatest buffer that we have is a vegetated swale. Like as part of this, I like to promote swales just because they do a lot of heavy lifting. They strip out TSS, they strip out TN, they strip out TP. I think they're actually a really underutilized stormwater treatment asset. because they just do a lot of heavy lifting. So if you see a vegetated swale and you can use it, great. But to answer your question, no, you can't just pump directly into a creek.
Good to know. Another question, what surveillance measures are in place to monitor the capacity of the GPTs in real time? And is it just proximity sensors, or are there also IP-rated cameras similar to GoPros?
Look, I'm smiling because at every stormwater conference, and Brad
Mm,
will testify to this is always a topic that people are talking about. And it
mm,
is, and rightfully so, because we should in 2025 be able to just click on something and say, oh, how full's my GPT?
mm,
But currently, there is, not that I know of, there could be a startup out there. There's nothing that has that reliability and that cost effectiveness together that is actually practical. And the reason
yeah.
is you may have, a wet sump GPT, you might have a level sensor or something up the top. How does that measure below the water level what the sediment and the
Mm,
settleables are? It may be able to measure, okay, you have this many floatables, or it may be able to measure certain other parameters. But to actually hit the water level and then go down from the water level to the pollution level and then measure that against what the sump actually is or the cleaning trigger, the technology is just not there yet. But please,
mm.
if someone knows something, please correct me. I'd love to be wrong.
Well, we'd love to prove you wrong. Yeah, this is something that I should protect, have looked into as well, and we are trialing some sensors for storm treatment assets. But yeah, to Dan's point, they are for dry sumps like gully pit baskets, like ocean guards, for example. The drama is around measuring pollution underwater currently. Now, a lot of companies have actually looked at this, and I haven't seen anything, brought to market just yet. So in the meantime, we're recommending regular inspection at suitable intervals of devices, popping lids and doing the old-fashioned look-see. But
Yeah,
yeah, there's some dramas. Even like just having a look, like you can only see the stuff from the top. Obviously, it's a hostile environment. You need to get a signal out of the manhole on concrete chamber, so you need some sort of antenna that pokes through the thing. So there are some challenges. But look, there might be some smart cookies out there that can solve that, because that's been an issue, I reckon, for at least 20 years.
yeah,
So watch that space. Yeah, that question just was from Telvinda Singh. So thanks to Telvinda. Yeah, Danielle's just reiterated the potential contaminant of concern might be PFAS as well, just
yeah,
FYI.
yeah.
Um, a question from Amrit Pun Maga. They ask, would it be easier for the council if they work with the water authority to discharge the water to their catchment? Is there a cost associated with doing this?
It's a great question, Amrit. So if council is the water authority and they get internal approval, which for me from the outside should be pretty easy. All right, we have supernatant water, you have a sewage treatment plant, you have a sewage network, let's cut costs, we'll put it in there, you guys treat it, away you go. But if it's a separate entity, for example, if you're City of Sydney Council, if you're Hornsby Council, and you say, oh, to Sydney Water, excuse me, I've got all these GPTs, it's costing us too much to discharge this water. Can we please get a trade waste agreement with you and pump it to your sewage network? Um, Always, in my experience, and hopefully this is changing, but that has never been the case, because they say, okay, you're fine, you can discharge to my sewage network, but we're going to need water quality testing to know the concentrations of everything in there. And based on that, we're going to then issue you a trade waste agreement. And if you break that agreement, we can fine you. So, maybe there's water authorities out there that'll have a more flexi approach to councils that are aiming to do the right environmental thing, but the bureaucracy associated with these water authorities and how hardline they need to be, typically in my experience, I haven't seen it yet. I would love to, though.
A lot of questions are coming through, Dan. It's super. It's obviously stirred a bit of discussion.
Well,
Another question, and I think it's from Telvinda, asks, how often does the 30-meter vegetation strip come into play? In practice, are they having to actually transport the water away to find this 30-meter strip?
it's a diminishing returns. So, okay, we've got a great vegetated swale. We can save money on cleaning this device, but it's half an hour away. Then you're like, by the time for us to, because how big's a combo vac truck from a tier one cleaning consultant? Maybe they can hold 8 kiloliters, 10 kiloliters. They remove everything out. That process takes half an hour, 1 hour, 2 hours, depending on the device. And then from there, they'll need to change their position and then decant. So it's all about time equals money. So maybe we have 30 minutes away, we have a great grass whale that we can discharge to. However, what we have 5 minutes away is another GPT that we can discharge into. So if you have another treatment measure that can handle it, that's close, then great. Okay, we're not going to dewater on site. The site's not appropriate. Work our way through all the alternatives, and you can have a look at the slides once this is all up. There's all the alternatives in there. And if any of those suit and they're closer and then the time versus money works out, bang, use that.
That is a great segue into the next question. And this is from Alan West, a trailblazing engineer from Kingston City Council. So, greetings, Alan. Thanks for joining us. Alan asks, or he says, first up, great prezzo, Dan. He asks, can you talk about alternatives to the 30-metre swale, such as dewatering into a council dedicated treatment system, e.g., a short filter swale, a bioretention, a filtera, a wetland, a silt basin, etc.?
Alan, yes, yes, and yes, all of that. They're great. I mean, the only thing I would say is we all know, or maybe it's not well known, that bioretention is actually a very, very delicate ecosystem. And if it gets smashed, this is like we're talking like classical bioretention. If it gets smashed with too many TSS and fine silts and sediments in there, it actually slows the hydraulic conductivity. So while you are correct that other treatment measures are a good option, I would be a little bit hesitant to dump it into a classical bioretention just because the death of bio is when the hydraulic conductivity drops down and they become swimming pools. Very costly exercise to replace. Filtera, different story. It's a high conductivity, but wetlands, filter swales, all great options.
Yeah, look, it's can I chime in as well? Like I'm doing a prezo at Frank Sydney conference around the question as to whether wetlands can function as ecological traps. So an ecological trap is something that attracts wildlife, but inadvertently the wildlife can't differentiate between it being a healthy area to be in, where they can reproduce, etc., or not. And long story short, a lot of wetland wildlife, or sorry, wildlife that is attracted to wetlands generally can't distinguish between a polluted wetland and a nice wetland, basically. So, long story short, we've got to be really careful about harming wildlife through inadvertently by having too much pollution in those wetland environments. And I'd argue that dumping a high volume of wet sump GPT fluid into a small volume wetland might actually cause a fair bit of harm. So, yeah, so just I agree with Dan, but I think we've got to be very mindful of the fact that these systems do attract wildlife. So just need to be mindful of that, Alan, if that helps. But if you can't know more about that, like I said, I'm doing a preso next month at Frank Sydney. Oh, sorry, this month, cheapers, a couple of weeks. Another question, I think it's from Tilvinda, but might be another anonymous attendee. They ask, isn't the primary objective of a gross pollutant trap isn't the primary objective of a gross pollutant trap to contain gross pollutants, i.e. 5 millimeter and bigger pollutants? So as long as these pollutants are not being discharged to during the dewatering, isn't the GPT doing its job? So can't we just discharge the small stuff wherever we like, Dan?
Well, look, I mean, so with a high performance GPT, the screen technology actually screens everything down to, 1 mil actually. And because of that, you're going to trap your coarse sediments, you're going to trap a lot of things, particulate bound, pollutants. Brad knows a lot more about it with the TN and the TP. But essentially, it does all get trapped in there a lot more than we think. So that's why it's not appropriate just to discharge it all. We need these risk mitigation measures.
Yeah, yeah. Look, wet sump GPTs can be a source of pollution. Like, yeah,
Yeah,
they
yeah.
basically what happens is like what they call biotransformation. So organic nutrients can dissolve and become quite readily bioavailable, basically, and cause dramas if they are discharged inadvertently somewhere else. So yeah, GPTs are important for capturing gross pollutants, but we've got to be mindful of they can be a source of pollution if they're not managed properly.
Yeah, on that. So that's why well, in my previous role at Optimal Stormwater, we would do cleaning specifications. And we'd also, for clients, we'd say, okay, based on your devices, based on your sump volume, and then based on your catchment sizes, we can estimate the cleaning frequency of your devices. Obviously, it's going to change depending on
Mm.
weather patterns and all these things. We can give you a first pass at what device needs to be cleaned, how many times per year, twice per year, 3 times per year, quarterly. So we would never recommend a wet sump GPT to be managed once annually. The minimum would be biannually. And the reason is for what Brad said, because organics get in there, cause anaerobic breakdown, and causes all sorts of dramas. They become a source of pollution if they're not maintained in line with the guidelines.
Cool. Next question, a bit of a doozy, and might not be able to answer this one, Dan, but look, I'm going to put you on the spot. Why not? Question from Talvinder Singh. They ask, Dan, with your comment regarding the materials that people dump down the stormwater network, is there any monitoring of the effects of this to marine and ecological life? As we all know, the treated stormwater is eventually discharged to the ocean.
Yeah, so that's the biggest concern here, isn't it? It's not going through a sewage treatment plant. So if people are doing the wrong thing and they're discharging down the stormwater network and then it's going directly into the ocean, yes, we might have primary treatment. Yes, we might have secondary treatment. But how effective is that treatment? Well, 80% of the time. It's not operational or working at 20% or less.
Yeah.
So exactly right. I know, Brad, you can talk more about the impact it has directly on the ocean.
Oh yeah, but even the waterways, we fundamentally urban stormwater is the number one threat to ecological health in our waterways, in our urban waterways, upstream of the ocean. And yeah, oceans aren't just the dilution and providing the solution to pollution. It's they are receiving environments themselves. I mean, I'm going to talk about PFAS in a couple of months on a fundamentals webinar. But yeah, the highest concentration of PFAS in dolphins in the world, Dan, pop quiz, is off Victoria. So fundamentally, and that's from stormwater. So fundamentally, our oceans are receiving environments. So we do need to protect them clearly, but equally, we've got to protect our upstream waterways as well. They often are a sink to pollution. So we definitely need to protect them appropriately. I think there's a misconception that waterways are just a conduit for pollution. No, no, the vast majority, or a big chunk of the pollution that enters them stays in them and causes damage. And obviously, they are vitally important ecologically, culturally, economically, etc. Kenza, who's
Kenza.
our brand new graduate engineer, who's probably sitting behind there. She is. Look at that. Uh, Sitting behind Dan. Welcome, Kenza. Kenza only joined us a couple of weeks ago. Kenza asks, this might be a Dorothy Dixon question. Did you put Kenza up to this, Dan? I don't know, but it's a
Yeah,
great
I had a gun
question.
to her head. I said, you better ask a question.
Kenza asks, how can water quality be managed right if there is no legislation to hold people accountable? What a great question.
Great question. Well, in the WSID compliance framework that was developed by Dan Rhodes and endorsed by councils and water authorities, there is actually a pathway to hold people accountable. Is it currently enforced? Well, not majorly. There are some examples of it being enforced, but we believe the industry is moving towards a position off the back of this work and others that people can be held accountable and should be held accountable.
Look, we're almost flush out of time, Dan. You've been bamboozled by lots of questions, and if you're keen to, so first up, well, thank you for all the questions that you've had. If you got any questions you'd like to ask Dan, please reach out to him. His contact details are there on the screen. So a big thank you to everyone who's dialed in today, and a big thank you for Dan for an amazing presentation and handling all these tricky questions. You've done a sterling job particularly for your first time as presenting an Ocean Protect webinar. Just a reminder, everyone, you will get a email with CPDs and the link to the recording and the slides, etc. And just a reminder, folks, we've got 2 more webinars to round off the year, and there's been a lot of focus around legality. And our very own Daniel Ryder is doing a presentation on this next month as part of the Stormwater Fundamentals. So if you're keen to chime in and learn some things and partake in some discussions and answer some hard questions, feel free to register for that. And there was a comment on PFAS from Daniela from Kingston Council. And look, if you're wondering what the hell PFAS is, you come to the right place. So, because in 2 months' time, we're going to do a webinar on it. Hot topic. But look, thank you everyone for dialing in today. It's another pearl of a webinar. Well done again, Dan. Well done for everyone who's joined in. And I hope you guys enjoy the rest of your day.
Ciao. Thank you.